Hello, everybody. Welcome to the third class in our Introduction to RStudio series. Today, I'm going to be talking about data transformations using R, which can include filtering and mutating and all sorts of cool things. Okay, so today we are going to be using the dplyr package, which is one of my all-time favorite packages in R. And if you've been following along, last week we installed dplyr into R. So we should already have that. If you were not following along with last week, please make sure you do install the dplyr package before anything today. Okay, let me get my laser pointer and here we go. So dplyr package contains all sorts of useful functions for manipulating data in R. And we load in our library, remember, with the library function. So library dplyr will take dplyr out of our bookshelf, we'll grab the book and put it in our specific R script. And then the other thing we want to do is we want to load in our names data again. And again, from last week, we talked about how to load in CSVs, how to change Excel files to CSV files, all of that fun stuff. And we're using the exact same data set that we were using last week. If you're having trouble finding it, in the video description, there should be a link to the Google Drive folder where you can download the names data. Okay, so all of that logistics, basic stuff out of the way. Let us dive right in with filtering. Okay, so filtering data, what we're doing is we're taking our large data set and we're just filtering it to be specific sorts of things. So if you want to filter it to be, oh, just people that I went to high school with, or just plants that are really used to arid climates. So whatever data set you have, you're filtering out just to meet specific requirements. Okay, so here are some examples. Filter, and then the first parameter in filter is the data set, which is going to be my data. If you're remembering, when we're loading in our CSV, we called it my data. And then we're going to return here only ages that are greater than 20. So you're seeing what's happening here is that we're filtering our data using logical operators. Logical operators we talked about in the very first class of this series. So here we're saying anytime the age is greater than 20, so age greater than 20 is true, we want to return that row. So if you run this, and I would like you to please run this, you should be seeing it's only returning rows of data where the person is greater than 20 years old. So run that and see how it works for you. Our second example here, we're going to filter my data, and names is not equal to Jenna. So here we're returning all rows in our data set except ones where name is Jenna. If you remember, this logical operator means does not equal. So names does not equal Jenna. So that's what we want. We don't want any Jennas in our data set that's filtered. And then our third one here, I'm actually creating a new data set. So remember, when we use the equal sign, we're assigning something to the global environment. So I'm creating data called 40 data. And then here's my filtering. Filtering my data where ages are exactly equal to 40. So when I'm doing this, I'm just taking rows of data where ages are equal to 40, and then I'm calling it 40 data. So now anytime in the future that we run 40 underscore data, it will return that data set. It's like saving a whole new data set. Just like my data is a data set, 40 data is now a whole new data set, but it just has data with people 40 years old. All right. We can really easily create specific filtered data frames through this method. And here we can see that we can expand upon it with and or, which are other Boolean or logical value operators that we talked about in the first session. Check this out. Create young old, which is a new data set, with ages that are less than 10 or greater than 80. Young old equals filter my data. And here we have ages less than 10 or ages greater than 80. So we're already putting these Boolean values to good use with our filtering. So this should give us a whole new data set that just has people that are under 10 and over than 80 years old. Okay, so using all of those examples that we just went through lightning speed, I would like you to slow down a little, take your time, and complete the following task. I would like you to create a data set called Young Vernon. Young Vernon should only include rows of data, so rows of my data, where the name is exactly Vernon and age is less than or equal to 50. So I don't want any Vernons that are older than 50, only Vernons that are 50 or younger. And then I would like you to please open Young Vernon in a new tab. So give that a go, and I shall wait. Please feel free to pause me. I'll still be here. So basically, I'm realizing I didn't create a solutions page here. So I'm just going to draw you right over. Oh, here we go. So our solution should be Young Vernon equals, and then we're going to filter out my data. And in this case, names should be exactly equal to Vernon. And Vernon is in our quotation marks, of course, because it is text. And here's our logical value operator, our Boolean, and ages less than equal to 50. So both these things have to be true for that row of data to be included in Young Vernon. And then you can just run Young Vernon and view it to see what it looks like. And you can also click it in the global environment to open it in a new tab like we practiced last week. Okay. And here is another challenge for you here. This one's going to be a little bit more tricky, and I will go over the solution for you properly in the next slide. So take your time with this, see what you can do. And what I want you to do is to create a data set called my_friends. And this is just going to have my friends in it. And what you're going to do is filter the data to include anyone 20 to 40 years old who is female. Okay, so just people that are 20 to 40 years old and female. Okay, and being the key word there. So please do that. And then call my friends. And then I would like you to go through and remove Jenna from my friends and call it again. Okay, I don't want any Jennas in my friends, but please do it in this order. Okay. And you should end up with 4 separate lines of code. Okay, and here is our challenge solution. It's kind of a lot, but don't you worry, we're going to go over it together. First thing is filtering ages from 20 to 30 and gender female. Okay, so my friends equals, because we're calling it my friends, and then we're filtering my data, which is the data set, and ages should be greater than equal to 20 and ages less than equal to 40. There are a few ways of doing this. This is how I did it. And I want gender to be exactly equal to female. So I want all 3 of these things to be true. I want you to be older or equal to 20, younger or equal to, oh, that should be 30, my bad. And I want gender to be female, okay? So that's all that. And you may notice here, I have this part on a new line. And in R, you can actually do that. You can press enter in the middle of your code, and it'll go down to the next line, and it'll still read it all as one line of code, which can be pretty important once you get to some longer lines of code where it would be all the way off the page. You can simply press enter, go down to the next line, and continue writing. And then I call my friends. So just call it and get the result of that to look at it. And then next thing I wanted you to do is remove Jenna from this data set. So how am I going to do that? Just going to overwrite it. I'm going to create a new my friends that is filtering out the current my friends. And I want names to be not equal to Jenna. So anyone that has a name, anything else than Jenna is fine. But if names is exactly equal to Jenna, removed. All right. And then below, I'm going to be calling my friends. And then it should return the updated my friends data set without anyone named Jenna. Okay, moving forward. Transformation functions. So dplyr has so many more ways to transform our data beyond our subsetting and filtering, which we just did. And here are a few really useful ones that I kind of keep in my tool belt. And of course, many more exist, which you can continue to add to your repertoire over time through looking at the internet or following along with these little classes or anything else. Distinct. Distinct removes duplicate rows, takes away any duplicates from your data set. So here's an example of that. My data equals distinct my data. So I'm taking away all of the duplicate rows from my data and then overwriting my data. So I'm renaming it as. Okay, and then we have arrange. Arrange is another really useful one. We're sorting rows alphabetically or numerically by a specific column. So here I'm saying I want my data to be equal to arrange my data ages. So I'm overwriting my data to be sorted by age. So R will automatically do this numerically. If we sorted by names, it would do it alphabetically. So this can be a very practical way to just take our data and then organize it into a form that's easier to see. Okay, and here is your challenge. So taking kind of everything that we've just learned, I want you to apply it to this. Our task, I would like you to please create male data that only has males, create female data that only has females, and then I would like you to ask R, so this is our logical operator, so I want a true or false, ask R whether the mean of male data ages is greater than the mean of female data ages. So on average, who's older, the dudes or the ladies? So please, your result should either be true or false. And remember, mean is calculated with the function mean. And then in here, we have X, which is our data set, $, and then the column name. We talked about that last class. So take the time, pause me. I'm all good. I'm just here drinking my coffee. So pause me and work on this, and then let's come back and talk about it. All right, here we have our solution. Male data is the first object that I'm creating. So remember, I wanted you to create male data that only has males. So we're making a brand new data set. Male data is just filtered my data where gender is exactly equal to male. There's our data with only males. Easy. And female data, exact same thing, but gender is equal to female. Again, pretty straightforward, just making data with only females. So we have these two brand new data frames that pop up in our global environment. And then the last thing I wanted to do is determine if the mean of male age is greater than the mean of female age. So this is where our mean function and our $signs come in handy. So here we're doing the ages column of male data and taking the mean of that. Is that greater than the mean of female data ages? That's what we're asking R. Are males older than females on average in our data sets? Well, R can very, very kindly calculate that on our behalf. So please make sure that your solution looks something like this and that you're able to get an answer that makes sense. As always, you can always ask questions, or you can check my example code to go through and see a bit more explanation and in-depth how it should work and all the solutions to everything that we've been going through so far. All good? All good. Next, we're going to be talking about mutate. Mutate is another one of those that I'm just always pulling out of my tool belt and using for all sorts of occasions. Mutate takes a data frame and then creates a new column based on certain criteria. For example, let's say I wanted to create a whole new column in my data called age 2. Okay, my data, so I'm overwriting it, equals mutate. The data to mutate is my data, and my new column, age 2, is going to be equal to, so I'm assigning whatever this is to age 2. It's going to be equal to ages plus 10. So this is how the column is defined, and this is the new column. So age 2 is literally just ages plus 10. So if your age is 21, age 2 is going to be 31. Pretty straightforward. And it keeps both of the columns. It's just going to add the new column to the end So it's going to have both ages as 21 and age 2 as 31. And that's going to do that for every single row and automatically calculate it. We can also modify our existing columns. So now that we've created age 2, and of course, please do follow along and type in the code that I'm putting in here. So now that we have our age 2 column, we can modify it if we want. Like say, I want to modify it so age 2 is actually multiplied by 0.2. So my data, I'm overwriting it, equals mutate. My data is the data that I'm mutating. Age 2 is the column to modify. So I'm giving it the exact same name. So I want it to overwrite. I could call it age 3 and make an entirely new column, but I want to modify the existing one. So I'm modifying it by multiplying it by 0.2. So every age in age 2 will be multiplied by 0.2 and overwrite the original age 2 column. Okay, so please do this. And then I would like you to do my_data $age2 to check out what the entire age 2 column looks like now that we've done all that damage to it, multiplying it by 0.2. Just get an idea of what it looks like. Okay, we're now going to shift gears just a little bit here, and we're going to talk about determining the class of variables. So the function structure str myData can be used to see the class of all of the variables in a data frame. Remember the function class that we talked about a couple classes ago? Class will just tell us the class of a single variable. Structure will tell you the class of every variable in a data frame. So it's pretty useful. And please use str on your data to see the class of each variable. In particular, pay attention to the age 2 column. Now, the age 2 column should be a numeric. So let's say we want to change the class of one of our variables. Let's say I really don't like age 2 being a numeric. I think that doesn't suit it at all. Well, variable class can be changed with mutate, just like we were using mutate before, and a class change function. So here's an example. If I want to change something to a factor, I use as.factor, and then the data frame, $, the column name. So I could do as.factor, and then my data $names. So all of the names are treated as a factor. Change to numeric, as.numeric, data frame, $, column name. Change to character, as.character. Change to integer, as.integer, all the same thing. So it's pretty straightforward with this. We just do as dot and then the character type, the class type that we want to be changing it to. Using that information, let's try a few things. First of all, I want to change ages to a character. Let's see what that does. My data equals mutate, and then my data, which is the data we want to be mutating. Ages equals as.character ages. So I'm overwriting my entire ages column to be as.character ages. And then I'm running structure my data, str my data, to check the structure of the data. And when we do that, we should see there's a huge change. Besides just being called a different class type, it's called a character now. What we're seeing is every age has quotes around it. It's being treated as text. So we can no longer do math with our ages column because it's text. They're names, they're strings. So that is a really important distinction. And sometimes we want it to be like that. Like, for example, house addresses. Sometimes house addresses, we want to be treating it as text instead of actual numbers that we can do math with. Okay, so here's your task. I would like you to please change age 2 to an integer. And then I want you to do the same thing, do structure my data and see what changes this caused. So use your observational skills and see what happens when you change a numeric to an integer. Does it look different when you run structure? So go right ahead and do that. And what you should be finding when you do that is that all of the numerics are actually rounded. They're rounded and they become integers. So anything with decimal places, decimals are gone. So you can see how that can be like a really interesting way to define what you're doing with your classes. Okay, and I hope you're starting to understand too the differences between the classes and get an idea of how one might be more useful than the other in different cases. Okay, new function, bind rows. Sometimes we want to combine our data sets. And of course, dplyr has us covered like it does with everything else. This can be done with the function bind underscore rows. Okay, so bind underscore rows is combining two data frames. Here, I want to combine young Vernon and my friends, which are two data frames that we've created in the past. Bind rows, young Vernon, my friends. And it should return the data frame that has both of those two combined. And of course, this works really well because the column names are the same between them. If we were trying to combine two extremely different things, R would have a harder time with it. So this is a very straightforward, the simplest use of bind rows. Okay. And of course, again, if I wanted to, I could name this something. I could say this is extended friends equals, and it would name a whole new data frame that's the combined ones. So just keep in mind the distinction between just running something and having it show up in your output, and then naming something, so naming it something new and having it pop up in your global environment, and overwriting something, which is naming it the same thing as something else that already exists and overwriting it or updating it. So please keep in mind those distinctions, because I don't want you accidentally overwriting things or wondering why on earth you don't have your new young Vernon, my friends combined data set. Well, it's because you didn't name it. You didn't actually take it and assign it to any name and put it in your global environment. And of course, I have a task for you. Please try combining 40 data and my friends, which are two more data frames that we've created before, and get an idea, again, how it works. More practice. And the more tasks I give you, the more sips of coffee I get to take. Okay, onwards. Paste zero, another handy function. Paste zero allows for us to add to strings. So paste zero, and then in here, we're putting what we're pasting. It attaches a string to the end of an existing string in a column. For example, let's say we want to change male and female to males and females with S's on the end. So here's an example of how we could do this. My data equals mutate my data. So we're mutating the my data data set and we're overwriting it. Gender equals, I'm overwriting the gender, paste zero, gender, comma, and then in quotations, S. So I'm adding the string of just S onto the gender column. So the whole gender column of my data will be like it is, but it'll have an S on the end added on. Pretty neat. And the zero in paste zero is just indicating that we don't want any space between it. So it's not going to be male space S. It's just going to be males with the S at the end. And then here, I'm just calling the gender column my data $gender to make sure that it actually works. And if everything is going according to plan, we're not missing any commas or brackets or weird spaces or anything like that, it should work. Okay, so we can also switch the order to add to the front. So back here, we did gender column and then add S on. But we can do it the other way. So here, I am wanting to mutate the ages column. I want it to say ages. Oh, I want it to say age first. So this is the string I want to add, age space. And then I want it to actually print the age that it is. So if Lacey is age 21, instead of just saying 21 in the ages column, I want it to say age space 21. So since ages is already a string, we change it to a string. We can actually do that. We can work with characters like that. So please give this a try and just make sure it works as expected. And now we have our dplyr mutate challenge. Excellent. What I would like you to do is add Mr. to the beginning of every name in male data, add Miss to the beginning of every name in female data, and then combine the two data sets with bind_rows. Okay, so remember we already made, way back, we already made our male data and our female data when we were checking the difference in mean between the ages of males and females. We already did that. So we have male data and female data in our global environment. And what I want you to do is add Mr. to the male data, Miss to the names in female data, and then combine the two data sets with bind rows. Please go right ahead and do that. And your result should look something like this. Okay, so here I'm overwriting male data. So I'm mutating male data, and names is now going to be equal to paste 0, Mr. at the front, and then names. So it should be Mr. Bernard, Mr. John, whatever, so on and so forth. And I'm going to add Miss to females. So I'm overwriting female data, mutating it, female data, and then I'm overwriting names, paste 0. So I'm pasting Miss dot space to the beginning of every name. So Miss Julia. Combine data. Here I'm combining the two new updated data sets, bind rows, female data and male data. And we should get a whole data frame that prints out that has all of these new Mr. So-and-so, Miss so-and-so for the correct male or female gender. And that's it. That is all I have for you today. So hopefully that worked out. And remember, I'll say it at the end of every video. If you have questions, you can reach out to me. You can also look at the reference materials to see a copy of the slides. You can see my R code if you're stuck on something and confused. And you can see a little reference sheet, which has a summary of the most important points of this. And hopefully all of that is useful to you. Okay, have a great day. Bye-bye.